Yo, what is up, guys? Welcome back. Today is a special day, episode 100 today. Definitely a very big milestone. 100 days of Leetcode, I guess. So, did I think I'd ever make it to episode 100? Probably not, but I did, and I'm pretty happy about that. So, I'm gonna keep going. I plan to just keep going until I get a job. And that'll, I'll be looking for something full time in January. So, I plan on going for the rest of the year, and hopefully in the future we see episode 200, episode 300. That's the goal, and I want to keep going, and it's definitely a grind doing these videos. I mean, we do this for about 2 hours, hour and a half, 2 hours every day, sometimes more, sometimes less. So, it's definitely a grind, and, but it's good. I really do enjoy it. I enjoy the grind, and, I enjoy documenting my journey. So, for the people that do watch, I guess it's pretty cool, and, it's pretty cool to see people comment and, kind of see where I'm going. And, bro. So I appreciate everyone that watches and clicks on the videos. So, we're going to get straight into it. So, let's check out our Pokemon 100. Looks like we got Voltorb today. Very classic. We'll check out the sound. Whoops. Sound. Let's take a look. I don't even know how to do that, to be honest. Voltine. There you go. Voltine. There you go. Let's take a look at a motivational quote of the day. But yeah, this video is going to be split up into two different parts. I actually have work in about an hour from now, but I got to leave in about half an hour. So, it's probably daytime right now, but when I come back, it'll be nighttime when we record the next half of the video. So, I was trying to get a little bit in now while I'm here. So, just got back from Chicago and everything. So, been gone about 3 days. So, just trying to get back in the groove of everything. But yeah, let's get a good quote today. Motivational quotes for work. Here we go. Let's do something that. This is a good one. I feel like this represents kind of goals and kind of how we made it to episode 100, and it's a pretty great goal that I achieved. This is by Tony Robbins. Setting goals is the first step in turning the invisible into visible. So there we go. I feel like that really resembles kind of what we're doing here, and setting goals, and now my next goal is to get to episode 200. So we've set that goal, and we're gonna keep going, and the ultimate goal here, everyone that's watching the video, is to get an opportunity to get a job. So so I guess that kind of resembles kind of what we're doing here, and to keep going, and to everything on here is hard. Everything learning is hard. Like learning each of these patterns and everything on here is really difficult, and I'm nowhere near. I wouldn't even say I'm good at it. I would say I'm probably pretty average, but I feel like the more consistent we be, and that's really all that matters. That's really all you can do. Be consistent and just keep going. So you only really need one person to give you a yes to kind of begin your career. So we'll keep going. We'll repeat that quote one more time. Setting goals is a first step in turning the invisible into visible. That is by Tony Robbins. Let's take a look. Curious, Tony Robbins. Who is this? An American author. Nice. Yeah. Setting goals is the first step in turning the invisible into the visible. Very cool quote. Anyway, let's continue here. Let's take a look at the problem of the day. Haven't even opened Leetcode the past couple days, so looks like a count the hidden sequences. I don't know. I feel like I'm trying to get something that's probably going to take about half an hour. So maybe we'll just jump into. We'll jump into something down here. Let's take a look at a previous graph problem. Just kind of get back into the groove of doing these graph problems. So I know rotting oranges is a BFS problem. I remember that. We have the clone graph, the walls and gates, number of islands. I believe this is all BFS. Let's go back to clone a graph. I know we've done this on it recently, probably about a month ago, but just to get that kind of DFS implementation back in our head, kind of see kind of how we're thinking, and I believe this is a pretty classic problem. Pretty classic graph problem. No, not this one. I don't like this one. Let's do course schedule. Let's go back to course schedule. Course schedule. Okay. We'll reset this code. Let's see when we did this. We did this April 13th, so shit, man, that wasn't long ago, bro. That was about 8 days ago. But yeah, let's take a look. There are a total number of num courses you have to take, labeled from 0 to m, num courses -1. You're given an array prerequisites where prerequisites I indicates A1, B1. Indicates you must take course B1 if you want to take course A1. Okay. For example, the pair 0, 1 indicates that to take course 0, you have to finish course 1. Return true if you finish all the courses, otherwise return false. Okay, so I know that when we kind of approach these, graph problems, obviously we want to create the adjacency list, but I feel like that's where I go wrong a lot. I'm not creating the adjacency list properly. So let's kind of make sure that we do that when we, sorry for all the banging. I think they're doing construction downstairs or something, but yeah, let's take in our num courses here, right? We can call our method here, adjacency list, pass in num courses. Oh no, it's prerequisites, right? Prerequisites. Let's take a look at this. Prerequisites. Is that how you spell it? Then I'm gonna spell it wrong probably. Yep, I did. Okay. So inside of here, we want to create our graph. So let's do graph is equal to, let's leave it as a dictionary for now. Let's do graph is equal to adjacency list. And we want to actually print our graph, of course, right? So the first thing we want to do here is we want to, okay, so how does it look? Okay, so we got, so to take course 1, you have to take course 0, right? So I guess in a way that we can kind of think about this is, I wish they gave us a little bit of examples with a graph, but I believe this should be a directed graph, so I guess we can loop over for, I guess, node in I guess for node in num courses, right? Because we have 2 num courses. For node in num courses, we can do adjacency list, sorry, graph is equal to, sorry, we'll do graph node is equal to this, right? So we'll generate the, the empty brackets for each node, and then we'll loop through and we'll go, okay, well, for edge in prerequisites, right? We can do, okay, well, AB is equal to edge, right? And then we can do, well, so we need to take course 1, you should have finished course 0, right? how can we think about this problem? We can go, well, okay. So let's say graph B is equal to graph B dot append. We want to append A, right? Now I guess we can return our graph. Let's check out what this looks like. Hint object is not iterable. Okay, that's because we need a range here. Let's put a range there. One, 0. Right, so to take course 1, you need to take course 0, right? So really we're kind of looking for loops here, right? Okay. So I think we're at a good start, right? Obviously here, the way we want to do this function here is I'm thinking, well, I know, because I've done the problem before, I know we have to do a DFS function, right? And inside of this DFS function, we want to pass in our graph. We want to pass in, man, I'm trying to think here. There's something wrong with my microphone now. Pass in our current graph. We want to pass in, we probably want a visited set, right? So probably our node, our visited set. Probably that's about it, right? This needs to go above this, right? Probably here. Let's start with that for now, right? To begin our DFS, right, we want to, well, I guess we want to go through each node, right? So for node in range num courses, right? Starting from 0, we want to check, well, okay, if node not in visited, right? Then we can call our DFS function, right? We call DFS graph node visited, right? We want to create our visited graph. Visited is equal to set, right? Now we want to create our DFS function, right? And in this case, our DFS function is a recursive function, right? That's for most kind of graph problems. So our base case here would be, well, I'm thinking, well, okay, if visited, sorry, if shit, bro. Okay, I'm trying to think here. What would be our base case? Well, we need a false, right? We need a false and we need a true. Okay, so the only way I can think about, well, if node in visited, then we definitely instantly return false, right? Because then we know that it's a cycle, right? For neighbor in graph node, right? We would need to check, okay, well, we want to run DFS on each different node, right? Because we're trying to find that path, right? So for neighboring graph node, we want to do, okay, we can do visitor.add node, right? Well, actually, no. We need it after the base case, right? Because then it's just going to return false every time. So graph node. Then we want to call our DFS function on the graph, the neighbor, and our visited, right? We probably want a different visited set each time we run this function, right? Well, I guess not actually, right? Because I guess in the first node, if we go through everything, then we'll know, right? So probably not actually. Right, we have our base case, return false. We add our visited every single time. Or do we need to check in here? If neighbor and visited. Okay, if not DFS neighbor, right? So if it returns false, we probably just want to keep returning false to the function, right? Otherwise, I guess we can just like return true, right? Take a look what that gives us. Oh shit, we're not really returning anything. Visited, right? We would want to return true. Right, if we get through all of this. We're only just detecting if it's false, right? Otherwise, we just return true every single time. Why would this return true? I wish in Leetcode you could step through, but why would this return true? So we start at 0. We go here. If node and visited. Let's do print. Gets here. Does it ever enter here? Okay, so it does return false. Somehow it still returns true. Oh, okay. Because we're returning true every single time. Okay, if not DFS neighbor, right, we would instantly return false. Okay, let's see if that. Nope. Okay, how does this return output false? How does this return false? Goes through each node, starts at 0, loops through the neighbors. It doesn't get through any of the neighbors, so it can't go here, returns true, right? And then it would call the next one if node not visited, which is not. gets through this. Visited.remove node. I think we need to get rid of the visited. Let's see if that helps. Okay. Looks like we're stuck in some sort of infinite loop. And I gave my heart to a party girl. Why is this? How you're tracking the visit nodes, especially using a single visited set for both detecting cycles and tracking visit nodes globally, which doesn't work correctly with this type of graph traversal. Okay. Using visited as a hybrid of both. So I guess we need a visiting, which we can, I guess we can just put here. That's visiting. Okay. If node in visited, if node in visiting, right, we would want to return false, right? Then if node in visited, we'd want to return true, right? For neighboring graph node, if not DFS graph node, okay, we need a visiting here. Visiting. We want to add all our visitor nodes, so we don't need to, we just need to remove our visiting. Visiting. Let's make this path. I feel like that's a little bit easier to understand, right? We make this path. Path. So we're adding every visited node, right? We also have to add every visiting path, right? So path.add node. We only need to remove the current path, right? I feel like visited should probably be after. Let's make this, it can be here. Nice. Okay. Well, that was a good problem. It was a simple recursive function, but it was good kind of like thinking about that. I feel like we have about 5 minutes left because I got to leave in a little bit. So maybe we can just get into another problem really quick. Let's do these three. Fine. Greedy intervals, mass graphs. Trying to think. You just maybe rip out an easy problem, pick out some random easy one. Let's go tags. Let's put the acceptance rate like the highest it can possibly be. Return length arguments pass. Display the first 3 rows. Okay, this is apparently one of the easiest problems on LinkedIn. Display the first 3 rows. Write a solution to display the first 3 rows of this data frame. I've never really worked with a pandas data frame before, but I'm just curious. What does it print? You need to return a pandas data frame instead of a class, non-type. Can we loop through a pandas data frame? Okay, I'm literally searching up how to iterate through this because I'm not sure. For index row in df, I don't know if this is the right way to do it, dude. Let's print index row. Can you print like that? I don't know, dude. Need to return a pandas data frame, dude. Don't give me code. Is this how you loop? I'm not sure if that's how you loop into data frame. Okay. Maybe the best way to do this would be using a count. It says here that we're looping properly, so I guess we can count plus or equal to 1. We can loop through these rows. Wait. We can go, okay, well, if count is less than equal to 3. I guess if count is less than 3, we can do something, right? Do something here. Then we can increment the count plus or equal to 1, so we get the first 3 rows. What do we store it in? How do we create a PD data frame? How to create Let's see, how do we create a PD data frame? I am not sure. Okay, I guess we just create an array or a list here. We add it to the list, apparently. Rows.add row? Would that be the way to do it? Oh no, we need append, right? Not add. Rows.append row, count. Then apparently we just return PD.data frame. We pass in the rows though. I don't know if this works, dude. I got no idea. Module pandas does not attribute data frame. Did you mean data frame? Maybe I did, man. I have no idea, bro. Oh, there we go. Oh, there we go. Well, that works out perfect. But okay. There's our next problem. I appreciate you guys watching. Whoops. I will be back in about 6 or 7 hours and we'll finish out these problems. So I appreciate you guys watching. I'll be back. Yo, what's up, guys? We're back. As you can see, it's dark outside now, so gonna rush through a couple problems. Probably, I don't know, 45 minutes to an hour, maybe. Definitely a little tired. It's been a little long day, so might be a little bit shorter of a video, but I guess we'll see. Believe we should have a new problem of the day. Let's take a look. Number of ideal arrays. Ugh, man, sounds awful. Let's jump into one of these problems. Oh, we did this one actually. Done run orange, done course schedule, done clone graph. Let's take a look at some graphs. Got some heat priority queue, task scheduler. Probably will get into some DP problems soon. Let's take a look at some of these graph problems. Let's take a look at number of islands. I think we've solved this one, but yeah, we have, yeah. Let's just take a look. I mean, we solved this one, yeah, about what? About 3 weeks ago. Okay, so we're given m times n 2D binary grid, which represents ones land and zeros is water. Return the number of islands, right? So an island is surrounded by water and is performed by concatenating adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. This is obviously a BFS problem. I mean, it's pretty obvious that it's BFS, right? Because we have an island, right? I guess you can technically do this with DFS, right? But I just think like the ideal solution here is definitely BFS, right? Because you could go DFS and keep, picking the right one, finding an island. But I definitely think here BFS is definitely the right solution here, obviously. So let's do our BFS solution, right? So let's do our rows is equal to the length of grid. Do our columns is equal to the length of grid. 0. Well, let's just print here. Let's print our rows and we print our columns. See what we got here so far. Are we getting an error? None is not valid. Guess we have to return something. Let's just return our rows for now. We can return an integer. Yep, so we got 4 and we got 5, so that looks good. Let's do a for row in rows, a for col in cols, right? So the way that we probably want to solve this problem is oh, jeez. Okay, let's do, colon cols. Okay, so we want to check, if grid row col is equal to 1, right? That's the base thing. We check and let's check and row col not in visited, right? So we need to keep track of different islands, right? Grid row is equal to 1 of row col not in visited. Then I mean We can use a helper function here. We can probably just do this. I guess just iteratively, like straight away. Trying to think probably what the best solution is here. I think we're gonna do it here with a helper function. It's kind of like the way I'm thinking about it, right? So we probably want to just initialize a visited set here. We want to call BFS graph, pass in. What do we want to pass in? Well, probably want to pass in our grid, right? No, we probably only need row call. Row call visited, right? Okay. Def BFS. Row call. Visited. Probably want our directions array too, not gonna lie. Alright, here we only need to check that's horizontally or vertically adjacent, right? So probably need to call directions array. Probably want to pass in tuples, right? So we want to do, well, up, down, to left, right. Let's make these capitals. Okay, looks better. We want to put in here, well, what would be up, right? So up would be -1, so not our x though. We'd want to go there. To go down, we'd want to go +1, so 0, 1. Left we go, that would be minus, so we go -0. And if we want to go right, we would go +1. What is these? Okay. So we've done our directions. We got our rows, we got our BFS function. Let's pass in everything. So probably want to initialize our queue, right? So we go, well, from queue. From collections. Import EQ, right? Probably want to create our queue, right? And we want to pass in, well, queue is equal to queue.append row call. Queue.append row call. Yeah, right. We just really need row call, right? Like visited or something. I guess Q is equal to DQ. Q.append row call visited, right? Q.append row call visited, right? We go while Q. We want to pop from our queue, right? So we would go, okay, well, let's do row call visited equal to queue.pop. We want to loop through, right? So we go, well, we want to loop through our directions array, right? So for direction, actually, now we go, well, for current direction and current. Okay, for new row, new call in directions. You want to do, okay, well, new row is equal to row plus new row. New call is equal to new col plus new col. All right, so we get our new row, then we need to check, well, is it in bounds, right? So if 0 is less than or equal to new row, but is less than rows, and 0 is less than or equal to new col, but is less than cols, and it's not in visited, right? And new row, let's do new row, new col, not in visited, right? So I guess now we could actually probably should visited.add row col, right? We also have to check and grid new row new col is equal to 1, and it's not in visited, and it's in bounds. I'm trying to think, am I missing anything else? Right. If it is, then we should just, if it is, then we should append I guess technically when we come in here, we can island count plus equal to 1, right? Make this island count is equal to 0, right? Because that's what we're going to return. I guess no, we wouldn't want to do this here. We'd want to do this in this for loop. So that's how we're going to know we have a new island, right? We want to loop through visitor.add for new row, new column. We calculate our new row. We check if it's in bounds. Then if it is, guess probably want to do, okay, visitor.add row column, right? Then we want to do visitor.add here as well, right? If we find something that's valid, add to our visited, and we want to q.append row col visited. New row, new col. We have our visited array, keeping track of them, right? And then what we want to do is we want to do, okay, well, we get through this. I think that looks good, right? We got a new row in here we want to loop through. And what we do here is we just, I believe we just return our island count, right? Island count. I'm missing a semicolon. Object is not iterable for row in rows. We need a range function here because this is not an iterable, it's an integer. Range cols. Okay. So I'm not actually appending anything. How are we not even incrementing here?
print getting here? How are we not even entering this? Like, what? Grid row call is equal to 1 and row call not in visited. Why are we not even getting inside of this loop here? I don't get it. Bro, I don't understand how we're not entering this loop. Like, we're literally running this and running this for. Checking. Grid row call. Looks good. Checking if it's equal to 1. And it's not in visited. How is this not running? Hell is this, dude? Got so much bullshit opened in. Why am I not getting to print statement? Something, it's gonna be something stupid like. Oh. Oh, whoops, I fucked this up. It's meant to be 1. Okay. See where that takes us. And I gave my heart to a party girl. And I gave my heart to a party girl. And I gave my heart to a party girl. BFS on these directions too. Directions. Oh my god, dude. What visited that ad? Should be new row, new column. That was a good spot. This is gonna need a double parenthesis. I already know it. Yep. There we go, dude. What a solution, bro. I'm goated. Goated with the sauce, dude. Alright. I believe this is another max area of island. It's another VFS problem. I mean, we can do this another day. I've done this one. Walls and gates. Have we done that one? I don't even remember. Looks like we have. Oh. Leetcode Premium, bro. Are you serious? Pacific Atlantic water flow. What the hell? Another BFS problem. This does look like a good problem, though. This is a good problem. I think I know how to solve this, to be honest. Well, at least I don't know. I'm not going to say I know how to solve it, but I think I have a good idea. I do believe that you can solve this. We're not going to solve this problem, but I'm going to talk about it for a bit because we'll solve this one tomorrow. I kind of just want to solve a DFS one. I'm hoping that this one's DFS one, but I don't know. Because we did just solve a BFS one. I would use BFS doing this. Reason is because I would start at this value and then I'd run BFS and check, well, is this cell less? I'd go here, right? It will flow to the Pacific Ocean, right? It'll flow this way to the Pacific Ocean. It'll flow this way to the Atlantic, and it'll flow this way to shit. Yeah, it'll flow this way to the Atlantic too, right? But for example, right, so you could go here, you could flow here, Pacific, right? Somehow we have to have some sort of thing that can tell that this is the Atlantic, right? Through surrounded regions. I don't know if we've done this one too. I think we have. Another BFS one, bro. These are good problems too, but I want to do a graph valid tree. What the fuck is this? Graph valid tree. Leetcode. Fuck. Number of connected components. Bro, are you serious, bro? Redundant connection. What is this? Yep, solve this one. Course schedule 2. We didn't do this one. Let's try and take a look at this problem. I do remember we were struggling with this one. I didn't want to submit it because I didn't understand it. So let's take a look at it again. For total num courses you have to take label 0 to n num courses -1. You're given a prerequisites where prerequisites I, A1, B1 indicates that you must take course B1 first before you take course A1. Do I know how to solve this? No. Do I have an idea? Yes. Let's create our adjacency list, right? Pass in our prerequisites. Let's get some music on here, bro, while we think about this. Just get the vibes going a little bit, you know? Low key. I've been listening to this new artist, bro. Let's listen to this shit. Kind of sounds like Juice WRLD a little bit, bro. I don't think I can get copyrighted because I don't really make any money on this stuff. So, like, I think it should be fine. Alright. Let's vibe, dude. Let's vibe. Okay. We want to create a graph here, right? Okay. Let's do... Oh, jeez, man. Okay. Alright, so we have our graph. What do we want to do? We want to loop over our num courses, right? So let's do, well, for I in range num courses, we can do graph I equal to this. We create the list. And what we want to do is we want to do, okay, so graph I is equal to this. Graph. I want to create our adjacency list. So what do we want to do now? We want to loop through each pair. So we go, okay, for edge and prerequisites, because they are edges, right? It's defined somewhere. I mean, is it an edge? Yeah. 1 to 0. So it is a directed graph, right? Directed graph. Okay, so for edge in prerequisites, right? Okay. Let's do AB is equal to edge, right? And when we read in the question, it says here that A1, B1 indicates that you must take course B1 first if you want to take course A1. Take B1 first before we can take A1. Okay, so it would be graph B dot append A, right? Because I think that should be good. We want to return our graph here. Probably print our graph here. We have an adjacency list with our prerequisites. Go our adjacency list and we pass in our prerequisites. Prerequisites. Okay. Let's print this out. Take a look what this looks like. I think this is what I'm looking for. Zero, one, one. Okay, so we start at node 0 and we go to 1. Right? That would be correct here. This case here, we start at 0. We go to 2. Two takes us to 3. 2 should take us to 1 though. Don't really understand this. 02031. What is it called? Paint, dude. It's kind of. Okay, it's that to take course 0, you have to take course 1. Let's take this as prereq. I want the keys to be the prereqs. That's what I'm trying to do here, right? How does... Bro, what? How does 2 here get... The focus take course 3, you should have finished both courses 1 and 2. I guess it kind of works because you can go 0, then we can go 1, 2, 3. Okay, I think what I'm having is right. I think, but I don't know. We have DFS here, so... Okay, so we have our graph, right? What we want to do is... How do we want to solve this? We're going to need some sort of like... Ah, man, fuck. Well, you want to go... Okay, well, for node in... num courses, right? We want to start from 0. Technically, could you start from 0 every time? I don't know. I think so. I mean, for node and num courses, right, we have to go, okay, well, we want to call that DFS. If node not invisited, then we want to call, okay, DFS. graph node visited. That's what I'm gonna have for now. Okay. Def. Let's do DFS. Do node visited. Sorry, graph node visited. And then we go, okay, well, okay, we enter our DFS, right? Well, what do we want to do? We want to keep looping. Well, okay. What could be our base case here? Let's do our path is just the set, right? The current. If node in path, I guess we can return false, right? If I don't know what my base case should be, right? But I know we go through here and we loop through our neighbors. So we go, well, for neighbor in graph node. If neighbor not in visited, graph a dot append. Do path dot append. If node in path, we want to return false, right? To Turn off this bullshit now. Okay. Okay. If maybe not in visited. I thought it penned. We obviously want to call our DFS function here, right? So we call DFS now. Pass in the graph, the neighbor, visited, path, right? When we see that current node, we want to add it to the visited.add node. Path.add node. I think we need to remove the visited. Visited.remove. No. DFS craft node visited set. To be honest, we probably want to return our path, right? Maybe we'd want to do path.add visited. I guess. Node and visited. Then what do we want to do? Target's detected. We want to return the path. I gave my heart to a party girl. Let's see what this gives us. Visited is not defined. Shit, we didn't even make our array. Visited is equal to set. Add node. Shit, did I actually do it, bro? No shot. Bro. No shot, I actually did this. What? Bro, no way I did this, bro. Bro, I was like, no fucking way. Like, bro, I was so close, bro. See where I landed here, bro. I mean, it's better than last time, bro. Last time I think from memory I really needed hella help. I don't think I could understand the question properly. You're close. I got several issues there. Bro, what? Bruh. Oh shit, man. What's that AI called, bro? DeepSeek, bro. DeepSeek. Bro, that was close, bro. DeepSeek, bro. Load, bro. That didn't do anything. Zero is unvisited. 1 is currently visiting. 2 is completely visited. So how's he building the adjacency list here? Okay, this is definitely an interesting way to solve this problem. We have our graph. We have our visited, right? But it's actually an array with 0 times num courses. Okay. Then we have a res array. In this case here, we have hashtag 0 is unvisited. Hashtag 1 is visiting. Hashtag 2 is visited. For node and range num courses. If visited node is equal to 0, right? Then we have to call, okay, if DFS graph node visited set. This case here, they only pass in a node. Interesting. DFS node. Then we want to return empty string. Otherwise return res. Okay. We have our DFS function. If visit node is equal to 1, cycle detected. If visited node is equal to 1, then cycle detected, turn true. If visited node is equal to 2, what is 2? Already processed. Already processed. Turn false. Okay, we mark the node as visiting, so we do visited node is equal to 1. For neighbor in graph node, if neighbor, sorry, get rid of this bullshit. If DFS neighbor turn true. Otherwise, visited node is equal to 2. Result.append node turn false. Result is not defined. Res. We have to return. Let's return it reversed. Interesting. After all the dependencies are processed, do we add the current node to the result list? So this is, I guess, topological sort in a way. Actually print out graph. It's a good problem. Let's just understand it a little bit really quick. Okay, so we do create our graph, right? We go through for node and range nums. If visited node is equal to 0, which it is, right? We want to do, okay, call DFS node, right? Now, if it returns true, we know it's a cycle, so it's impossible to return this, right? So we go through this, right? We make the visit node is equal to 1, then we go through the neighbors, right? The DFS is in the neighbor. Call DFS neighbor, right? So we call 1, right? So we go there and we check, okay, is 1? No, well, no, it's 0. Then we make it 1. We go through the neighbors. There's nothing in the neighbors, so this doesn't even enter. We go visited node is equal to 2. Res.append node. We would append 1. And then we would return false. So then we go back, return false. Doesn't enter here. Then we make the visit node is equal to. We'd append, return false. So we get 1, 0. Let's do a better one. Go through here, right? Okay, we go for node. We have 0, right? We call DFS node. Make it equal to 1. We go through the neighbors, right? We go for 1, do the same thing, go through 1, right? Do the same thing, go through 3. We get to 3. We see that it's empty, right? Then we make 3. We append, right? Then we go back to 2, right? We finish this. We'd append 2. Okay. Or 1. Sorry, we go back to 1. We'd append 1. Then we go back to 1 here. Turn false. Go to 2. Right, we see that 3 is already processed in this case, right? Because then we go back to 2. We go to 3. Right, we see that 2 and 3 are already processed, so it's fine. And we go back to 0. We'd append 0. Interesting algorithm. Interesting algorithm. I really like that. Interesting algorithm for sure. I couldn't really understand this last time, so I'm happy that I could understand it this time, which is better. Maybe I just wasn't as locked in last time. I don't remember what happened. I don't know if I was sick or something, maybe, or... redundant connection. Good. I think we would say this one for tomorrow. Do that one tomorrow. But yeah, I appreciate you guys watching. A little bit of a shorter video today. I think we went for about an hour and a half. So, well, I guess technically we usually go for that long, but yeah, I appreciate you guys watching. It's been a little bit of a long day. I'm definitely gonna head to bed. So, appreciate you guys watching. See you tomorrow for another video.